Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A hotel front desk agent stares at 47 unanswered guest emails. Half are in languages she doesn't speak. A VIP insists his reservation was for a suite. The system shows a twin. Then an AI agent steps in, translates every message instantly, checks room availability, and answers the pet policy in fluent French. That agent? Built in a single Azure AI Foundry project. No glue code, no 5 different services. One project, one deployment. By the end of this video, you'll walk away with 3 concrete skills you can actually use on Monday. First, you'll understand the hub and project architecture that stops teams from scattering credentials everywhere. Second, you'll build a retrieval-augmented agent that grounds answers in real company documents. No hallucinations. Third, you'll see how the AI 901 certification validates this knowledge and positions you for AI developer roles. Industry observers note that enterprise AI adoption has accelerated sharply as generative AI went mainstream. An old-school FAQ chatbot could answer maybe a handful of preset questions. What are your hours? Then dead end. A modern agent built on Azure AI Foundry understands your entire policy library thanks to retrieval-augmented generation. That means the model looks up real data from your documents before answering, so it doesn't make things up. And it handles a wide range of nuanced user intents. Pet fee? Early check-in with a dog in a crate? Do you allow emotional support peacocks? It knows. That's the gap this platform closes. Azure AI Foundry is Microsoft's unified platform for the entire AI lifecycle. Everything is governed by role-based access control, RBAC, that controls who can deploy models or access data, and a hub topology defines shared connections that projects inherit, so you don't scatter credentials. At the center, you've got one workspace where you discover models from a catalog of thousands, experiment with prompts in a playground, ground answers with your own data using retrieval-augmented generation, build autonomous agents that can call APIs and tools, and wrap it all in responsible AI monitoring and evaluation. No more stitching together 6 different consoles. It all lives in one project. Understanding who does what in Foundry is key. The solutions architect designs the hub topology, connections to models, search, and Key Vault, and sets security policies. The AI engineer builds agents and deploys models within projects. Data scientists feed proprietary data and evaluate models. Security admins lock down secrets and monitor for abuse. And business users access the finished copilots without touching any code. Each role has a clear job, and Foundry's RBAC enforces it. Time for a quick recall check. What role is responsible for designing the hub topology so that multiple project teams don't step on each other? Pause. The solutions architect typically handles that. They set up the hub layout and access policies so everyone works safely without cross-contamination. These aren't hypotheticals. Insurance companies auto-extract claims data from scanned PDFs. HR teams built a chatbot that answers policy questions straight from the handbook. Support desks triage tickets by intent using language understanding. Legal departments flag risky clauses in contracts. Devs generate code snippets from internal documentation. Logistics teams parse shipment PDFs to update inventory automatically. 6 business problems, 1 platform, and each tile shows exactly which Foundry service handles it. The architecture is built on a clean chain. Your Azure subscription holds a hub. That's where you define shared connections to models, search, and Key Vault, plus security policies. From that hub, you spawn projects. Each project isolates a specific application's code, data, and deployment, but inherits the hub's guardrails automatically. No more scattering credentials across 20 different services. Inside a project, you wire up the AI services your app needs, and that assembly exposes a single endpoint your front end can call. The hub is where you define your shared resources exactly once: the Azure OpenAI connection, the search service, your Key Vault. Every child project inherits those connections automatically. For example, a 500-person organization could roll out 200 AI projects with 0 duplicated secrets and 0 mismatched policies. 1 secure baseline, dozens of isolated sandboxes, a mistake-proof setup, whether you're a team of 3 or 300. A project in Azure AI Foundry is much more than a folder for organizing files. Think of it as the complete workspace where an individual AI application comes to life. Every project contains its own model deployments, prompt templates, evaluation results, AI agents, application settings, and connections to enterprise resources. At the same time, the project inherits shared governance, networking, and security policies from its parent hub. This separation allows different teams to build independent AI solutions without duplicating infrastructure or accidentally affecting each other's work. As organizations build dozens or even hundreds of AI applications, projects become the natural boundary for development, testing, deployment, and ongoing operations. Time for a quick recall check. What's the relationship between a hub and a project in Azure AI Foundry? The hub centralizes shared resources and security policies, while a project is a separate workspace that uses those shared services but manages its own code, data, and deployments. Think of the hub as a factory floor with shared utilities, and each project as its own independent production line. Developers constantly mix these two up, so let's set the record straight. On the left, Azure OpenAI hands you raw access to models like GPT-4o and DALL-E. It's an LLM as a service. On the right, Azure AI Foundry wraps that same model access and adds an entire platform. You get the model catalog with thousands of models, native retrieval augmented generation, agent orchestration capabilities, evaluation dashboards for quality and safety, and a project-based governance model. If all you need is a single LLM call, Azure OpenAI is enough. The moment you need an enterprise AI system that stays safe, retrieves real company data, and is manageable across a team, you pick Foundry. Open your browser, head to ai.azure.com, and log in. This is the dashboard you'll live in. On the left rail, you'll see the core experiences. Always start in projects. That's where every application lives. Below it, the model catalog gives you a searchable gallery of thousands of models, from massive language models to tiny vision experts. Deployment shows every endpoint you've created, and the prompt playground lets you test prompts before writing a single line of code. There's also an evaluation tab with dashboards for safety, quality, and latency. You don't need 6 different portals anymore. One project now contains the entire AI lifecycle. Every AI agent starts with a foundation model, a massive neural network pre-trained on billions of text, image, and code examples. But here's the trap. If you pick the wrong model category, like a language model for a vision task, you'll burn hundreds in inference costs before it even gets your intent right. In Foundry's catalog, these models split into 4 categories. Language models like GPT-4o, Llama 3, and Cohere handle text. Vision models such as Florence analyze and tag images. Multimodal models handle text and images together. GPT-4o with vision, for instance. And specialized models lock onto a single job. Codex generates code. Whisper transcribes speech. Choose the right category before you ever touch a prompt, because the cost of rework is real. Here's the single mistake that makes first-time AI projects fail: deploying a model without checking its benchmark scores. Foundry puts the hallucination risk and latency numbers right in the catalog. Skip them, and you'll waste weeks debugging a model that was never right for the job. Quick check that you didn't just skim the categories. What kind of model capabilities would you combine for a hotel concierge that chats and describes room photos? Pause. A language model for text conversation and a multimodal model, one that can process images, to describe those photos. Getting this combination right stops you from burning tokens on a model that can't even see what it's supposed to talk about. The model catalog is more than a list of available models. It's a decision engine. Every model represents a different balance between intelligence, speed, cost, and specialization. Larger reasoning models often produce higher quality answers but require more tokens and longer response times. Smaller models respond quickly and cost less, making them excellent for routine business tasks. Some models specialize in conversations, others in coding, image understanding, speech, or multimodal reasoning. Before deploying any model, ask 4 questions. Does it solve the business problem? Does it meet latency requirements? Is the operating cost acceptable? And does it support the capabilities your application requires? Choosing the right model is one of the most important architectural decisions you'll make, because it affects every conversation your application will ever have. Creating a project in Foundry takes less than a minute. You give it a name, like Hotel Agent Demo, pick your hub, and hit Create. The hub already has all the connections to Azure OpenAI, AI Search, and Key Vault, so you don't set up any credentials. Behind the scenes, Foundry provisions AI services and storage, and applies the hub's security policies automatically. In seconds, you have a fully isolated sandbox where every model call and document upload is separated from other projects. That's the power of the hub and project model: fast, secure, and impossible to cross-contaminate. Many people think prompt engineering is simply writing clever questions. In reality, it's an iterative engineering process. Every prompt should be treated like application code, designed intentionally, tested repeatedly, evaluated objectively, and improved over time. Azure AI Foundry's Prompt Playground provides a safe environment to experiment with different system instructions, temperatures, response formats, and conversation styles before integrating prompts into production applications. By testing prompts early, developers reduce hallucinations, improve consistency, and create more reliable AI experiences. Successful enterprise AI applications aren't built from perfect prompts. They're built through continuous experimentation and refinement. Now that you've walked through the prompt playground and tested two key settings, let's lock in the learning with a quick checkpoint. Which two settings did we just adjust to control the agent's tone and make responses reliable? Pause. The system message. That's the instruction that defines the agent's persona. And the temperature. A low temperature like zero point 0.3 makes the output more deterministic and safe for support. Get those right, and you're already ahead of teams that skip testing entirely. Let's move from a single prompt to a full conversation. I'm in the chat playground right now. I've set the system message to, "You are an IT help desk agent. Respond professionally and ask for details when needed." Now I type, "My VPN isn't working." Watch what happens. The model doesn't just spit out a generic fix. It asks a clarifying question. Are you connecting from home or the office? What error message do you see? That multi-turn capability is what makes a chatbot feel human. Conversation history is preserved automatically. Each new message includes the entire exchange, so the model remembers context even after 5 or 6 follow-ups. I'm now capping max tokens at 500. That prevents the agent from rambling with the 3-paragraph encyclopedia when a short, precise reply would do. This is exactly how you prototype a production help desk agent without writing a single line of code. Iterate here until the conversation flow feels natural, then move to the SDK when you're ready to integrate it into an app. You just built a chatbot in Foundry's playground. It sounds great. Until you ask it, "How many PTO days do I get?" It will confidently tell you some answer, maybe 10 days. But that number never existed in your company's handbook. The model isn't lying to you. It's hallucinating because it has no access to your actual data. Here's the gap that catches every beginner. A model can only answer from what it was trained on, and its knowledge is typically cut off at a past date. To build a trustworthy enterprise agent, you must ground it in your own documents. And that's exactly what we're doing next. Retrieval Augmented Generation, RAG, is the mechanism that fixes the hallucination gap. Imagine an employee asks, "How many PTO days do I have?" That question hits Azure AI Search, which has already indexed your hrpolicy.pdf. Search retrieves the exact paragraph that mentions PTO entitlements. Those chunks get injected into the prompt right before the model responds. So the model isn't guessing. It's reading your document. It then generates an answer like, "You have 15 days," based on the 2025 Employee Handbook, page 4. Your data stays within Azure's secure environment, with privacy protections and no training of Microsoft's models on your sensitive files. Quick checkpoint. See if you can answer before the reveal. Why do many enterprise teams prefer RAG over retraining a model on their proprietary data every quarter? The answer: RAG gives the model real-time access to your private documents, so it can answer with up-to-date company-specific information. No retraining required, and your data stays inside your own Azure environment. That's what turns a flashy demo into a system your compliance team will actually sign off on. A chatbot just answers text. An AI agent acts. Picture the hotel agent from the Coursera course. A guest types, "Cancel my spa appointment and book a dinner at 7. The agent perceives, intent is cancel and book, entities are spa and dinner. Then it reasons, check dinner availability, confirm spa cancellation, decide the order of API calls. It acts, calls the booking API, sends a confirmation email. And it learns. If the guest later corrects, "I said 8 p.m., the agent updates its understanding and asks next time. This loop, perceive, reason, act, learn, is what turns a language model into an enterprise agent that can actually take actions on your behalf. Here's a real scenario. A developer leaves the company. Their old script tries to call the Foundry endpoint at 3 a.m. In a messier setup, maybe it would succeed because a key is lying around. But with Azure AI Foundry's layered security, that script is dead the instant the developer's Entra ID account is deactivated and their RBAC role is revoked. Managed identity means the agent itself never needed a hard-coded API key anyway. It authenticates automatically. Key Vault holds any secrets, and if someone deploys to a private endpoint, the traffic never even crosses the internet. This is defense in depth, built into the platform, not bolted on later. Microsoft mandates 6 responsible AI principles, and Azure AI Foundry bakes them into the platform. Not as optional checkboxes, but as active guardrails. The most concrete one? Fairness. There's a well-known pattern where a hiring model that's not evaluated can silently discriminate. For example, penalizing applicants from certain zip codes. Foundry's built-in bias detection would surface that pattern before any candidate is affected. Content safety filters are on by default, so you can't accidentally launch a chatbot that generates hate speech. And customer data? It stays in your region and is never used to train Microsoft's generic models. That's a non-negotiable requirement for any enterprise contract. In the next scene, we'll imagine monitoring a golden data set. Maybe a model scores 0.95 intent accuracy, but lags 800 DRMs on complex queries. Those numbers are hypothetical, but the process is exactly what production teams use. Building an AI application isn't the finish line. It's the beginning of continuous improvement. User expectations change, business documents evolve, and new foundation models become available regularly. Azure AI Foundry supports ongoing evaluation by measuring response quality, groundedness, safety, latency, and operational metrics over time. Rather than asking whether today's responses are acceptable, organizations should continually ask whether tomorrow's responses remain accurate as their environment changes. Continuous evaluation transforms AI development from a one-time deployment into an ongoing engineering practice that steadily improves both reliability and user trust. Let's step back and view the complete enterprise architecture. Users interact with an application through a web portal, Microsoft Teams, or another business interface. Requests flow into Azure AI Foundry, where AI agents orchestrate the conversation and determine whether additional knowledge or external tools are required. Azure OpenAI provides language reasoning, Azure AI Search retrieves enterprise knowledge, Azure Storage houses business documents, and Azure Key Vault protects sensitive secrets. Microsoft Entra ID authenticates users and services, while Azure Monitor and Application Insights continuously observe application health and performance. Together, these managed services create a scalable AI platform that separates application logic, enterprise knowledge, security, monitoring, and AI reasoning into independent but coordinated architectural layers. This modular design makes the platform easier to secure, scale, and evolve as business requirements change. Now let's lock in what you just built. Every security-sensitive piece, API keys, connection strings, is handled without a single hard-coded credential. Quick checkpoint. As for costs, a typical enterprise chatbot handling thousands of queries a month pays only for tokens used. Setting a budget alert in the Azure portal is a one-click operation that avoids surprises. Provisioned throughput can cut per-token costs further when workloads are predictable. Learning Azure AI Foundry opens far more opportunities than simply building chatbots. Organizations increasingly need professionals who understand how to design, secure, deploy, monitor, and govern enterprise AI solutions. AI engineers build intelligent applications. AI platform engineers manage the underlying infrastructure. AI solutions. Architects design enterprise AI platforms. AI security. Engineers protect AI systems from emerging threats, and LLM engineers specialize in prompt engineering, retrieval systems, evaluation, and optimization. Azure AI Foundry provides the common platform connecting many of these roles. Combined with hands-on experience and certifications, such as AI 900 or AI 102, these skills position you for some of the fastest-growing careers in cloud computing and artificial intelligence. Let's recap the 3 skills you now have. 1. You understand the hub and project hierarchy, a central hub for shared security and resources, child projects for your apps, so you can scale safely. 2. You know how to build a retrieval augmented generation agent that pulls real company documents into accurate answers, no hallucinations. 3. You have a clear path to the AI 901 certification, which validates these fundamentals and opens doors to 6-figure AI developer roles. Now pick one thing, open the portal, create a project, and start building. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson. Build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.